Hi, this is Mrs. LaBarbera. This is AP Physics Mechanics C. Today, I'm going to go over an example of circular motion and conservation of energy. The model of a roller coaster shown consists of a ramp and a circular loop. A small block of mass m starts from height h with speed v equals to 0 and slide without friction down the ramp and around inside the loop with radius h over 2. Position P is a point on the loop at angle theta with the horizontal as shown. Express all algebraic answers in terms of m, h, theta, and fundamental constants as appropriate. Part A, derive an expression for the speed of the block at point P. So because the track is frictionless, so we know total energy is conserved. So if we choose in the beginning is point 1, at P is point 2, we know the energy at point 1 equals to energy at point 2. Energy at point 1 is mg big H. Energy at point 2 is mg this H plus 1/2 mv squared. What is this H? This H equals to h over 2 plus this part. And we know the radius is h over 2. And this side in the triangle is the opposite of theta. So this side equals h over 2 times sine theta. So the h at point 2 is h over 2 plus h over 2 sine theta plus the kinetic energy at that point. So again, here this part is h over 2 sine theta. The two added together is the height of 2. In this equation, we can cancel out m. We can multiply both sides by 2, simplify it, and you'll have v equals to square root of gh times 1 minus sine theta. On the following diagram, draw and label vectors to represent forces, not components on the block, when it is at position P. Each force must be represented by a distinct arrow starting on and pointing away from the dot at position P. So at this point, there are two forces. One is mg going down, the other one is normal force by the track pushing the block inward. Part C. Derive an expression for the magnitude of the force exerted by the hoop on the block. That is the normal force when it is at position P. If you need to draw anything other than what you have shown in Part B to assist you in your solution, draw another picture, use the space below. So basically we have to find n. What do we know? We know the speed at that point. So let's go back, take a look at the picture. So this is a picture with horizontal, this is theta. We know there are two forces acting on it, normal force and mg. So because it's moving, has a speed and changing directions, we know there has to be centripetal force. This centripetal force is provided by mg perpendicular plus n. This mg has two components, mg perpendicular and mg parallel. So the mg perpendicular and n are the one provided centripetal force. So n equals to centripetal force minus mg perpendicular. So what is mg perpendicular? Mg perpendicular is this part. If you draw a triangle here, mg perpendicular actually equals mg times sine theta. So n equals mv squared equals gh times 1 minus sine theta. R is h over 2 minus mg sine theta. So again, simplify this, h and h cancels. Then when you divide by 1/2, you multiply it by 2. So n becomes 2 mg times 1 minus sine theta and minus mg sine theta. Simplify this. You should have n equals mg times 2 minus 3 sine theta. Part D, calculate angle theta L in degrees at which the block leaves the hoop. So when the block leaves the hoop, what does that mean? That means you don't have any more normal force. Normal force is 0. Look, mg is not 0. That means 2 has to be equals to 3 minus sine theta, because 2 minus 3 sine theta has to be equals to 0, so this 2 has to be the same. 2 equals to 3 sine theta L. So from here you can theta L equals to inverse sine 2/3. Put that in your calculator. You should have 41.8 degrees. Last part, the small block now is replaced with a small sphere that also start at height h. So now there is enough friction to allow the sphere to roll down the ramp without slipping. Identify how the new angle theta n when the sphere leaves the hoop compare with the angle theta L calculated in part D. So in part D, we know when you have just a block, it leaves at 41.8. But now you have a sphere. Is the angle going to be bigger, smaller, or the same? So let's take a look. What happens when a sphere comes down? It will roll because it says there is enough friction to allow for it to roll. When it rolls, that means it will have rotational kinetic energy. And where is that rotational kinetic energy coming from? It comes from the original gravitational potential energy that's transformed into rotational kinetic energy. So V will be smaller. Now, since n equals mv squared over r minus mg perpendicular, when the sphere leaves the track, n equals to 0. We know m and m can cancel, so this part equals to 0. M and m can cancel. That means v squared over r minus g sine theta has to be 0. By the way, mg perpendicular equals mg sine theta. M cancels, so the second part becomes g sine theta. From here, we can solve for theta. Theta equals the inverse sine v squared over gr. So as v decreases, theta also decreases as well. So your answer should be theta n should be less than theta L. That's it. I hope it helps. Thanks for watching. See you next time.